So yeah, this is material on this idea of like real valued coherence. So to kind of reiterate the basics. Oh, and yeah, who would like to volunteer as interviewer?
I can.
Cool. Okay, yeah. So this is some material that I put together on the idea of real valued coherence, which I think I've mentioned briefly at other times. Um, so to kind of give a timeline, this was kind of my idea for this project in 2020. Like, I mean, I've been thinking about what it takes to merge updateless decision theory with logical induction since logical induction came out. Um, so since like 2016, I think, but the kind of particular shape that the particular shape of that we've been exploring throughout this project is more or less an idea that came to me in like spring of 2020. And at that time, real valued coherence was like one of the centerpiece ideas. So real valued coherence is just supposed to be like the analog of propositional coherence, but rather than for like the Boolean algebra, we're doing it for like the algebra of real valued variables. So like the algebra of random variables in normal probabilistic language, or the logically uncertain variables in the terminology in the logical induction paper. So to kind of motivate the idea from Bayesian logical induction, so here's the 4 assumptions of Bayesian logical induction again that you've seen before. And I've said before that the 4th constraint seems kind of incomplete in some sense, right? So this requires the distribution over large sentences to marginalize out to the small beliefs, or I should say, like, it requires the distribution over the future market states to marginalize out to the current beliefs on those propositions. However, a distribution a distribution obeying those constraints may still disrespect other small beliefs about the future, such as a belief that the probability of phi and the probability of psi are correlated with each other.
On the n.
Yeah.
So
Like,
sorry. How would that belief look like? What does it mean to have that belief? Like, what is the sentence representing that belief?
So one sentence that would, yeah, that's a good question. So
should that one maybe be Q Blackboard bold Qn equals normal Q sub n minus 1? Like tomorrow's price will be identical to today's?
No, that's not for 2 different days. That's for 2 different beliefs on the same day, and the day is for about like tomorrow's day.
Okay, never mind. I see. Yes.
Yeah, so I guess maybe my statement is wrong here in the sense that, like, if the, like, we could express this like tomorrow's phi and tomorrow's psi are correlated by a belief about the probability of conjunctions. And so the
so like the probability of phi and psi are greater than probability of phi times the probability of psi. And this is all embedded in the probability n minus 1. So like probability n phi and psi is greater than probability n phi, probability n psi.
I think because they're correlated, like the probabilities are correlated, not the individual propositions. And so it's like the probability that that's
Sorry, Paul. Yes, thank you. Sorry, is it possible for you to have a marker like to draw on this whiteboard or
no, I don't
okay?
think so. So like I'm trying to say something like, well, you're saying like these probabilities could be correlated and still be independent, so that the
statements are independent, the probabilities are correlated.
exactly, yeah. So what you said
I see
is,
what you mean.
So okay, anyway, I guess my epistemic state is I've become uncertain about whether this is a good example. Maybe we can state some small belief things that actually do follow from constraints 1 through 4, that this correlation would have to be respected. But another example that I'm like more confident in would be like that Pn of phi has high variance. Like this belief that Pn of phi has high variance could be a small belief at day n minus 1, but it's not going to be enforced on this distribution on the future beliefs based on constraints 1 through 4.
Yeah. Also, I've sort of an example for like this one. So like probability n of phi is in some range, and probability of psi is in some range. Is probability of this fact is greater than the probability of like the multiplication of those probabilities being in that range. Right.
Okay, cool. Yeah. So I think that's a good expression, also in the sense that it illustrates, I think, why constraints 1 through 4 don't force this kind of thing, right? Like because it's a statement about the relationship of the prices at the next market state, rather than a statement about the relationship of the propositions, then I believe constraints 1 through 4 will not like enforce that on this distribution.
So this correlation is taken from the actual market prices on the day n minus 1. So the actual market prices n minus 1 are like follow this like inequality, like the multiplication is less than the market price for the conjunction.
Right.
Yeah, and this is not going to be followed from this form, right?
Yeah, and intuitively, it seems like that's kind of on par with this kind of constraint number 4 of like, well, our distribution over future market prices is supposed to reflect the small beliefs. And so this is some kind of inadequacy of constraint number 4, and allows us to have some weird probabilities over future market states for these large sentences that satisfy all of these rationality constraints. And so real valued coherence seems like a way to try to improve upon that. So this is just kind of a list of different things that we might want. So this, I hope you can see my mouse. This arrow is like, so we have this big multi-dimensional distribution on the future market prices. And then we have our small belief about, like, we have a small belief that's like a distribution over the P of phi on day n that maybe has like this shape, and we want this big distribution over future market prices to marginalize to this.
Sorry, what do you mean marginalize?
Yeah, so marginalize as in, like, this is this big multi-dimensional distribution. It has a dimension for what's the price of each proposition.
Yeah.
And when I sum out all of the other dimensions,
Yeah.
like I integrate over everything else except the probability of phi, then I get a like probability density function for what's the price on phi.
You don't get it. You get just the probability of phi. Oh no. You get the discretized version of the probability distribution. If we are in the discretized world.
Yeah. And you get the continuous probability density function if we're in the continuous world. And yeah, I'm saying that should match the small beliefs, like, because we want the large beliefs to reflect the small beliefs. And then similarly, if we have, for another proposition, a bimodal distribution, like, we want to marginalize to that. And then similarly, when we consider these two propositions together, if the small beliefs talk about not just the correlation, but like what's the specific probabilistic relationship between these two variables, x and y, which are these two different prices, then we want the marginal to finding this joint distribution to also come up to equal this joint distribution. So those are some things we might want. Another thing we might want is, like, if we have this, like, this is a narrower thing, like if we have just specifically this belief that it's going to be above 0.2, like, we should reflect that. And then a more complicated thing, we might say, well, like, any expression or some specific class of expressions, then, oh, I put the brackets wrong. I meant the closed parenthesis to be here. But, like, we might have constraints based on any expression or some class of expressions like this. So things of this sort are, of course, only possible if the small beliefs place consistent demands on the future. So we can't just demand that we can't just add to 4, like, or add a fifth constraint that represents, like, all these things we might want, because small beliefs, although they're propositionally consistent, can be inconsistent in other ways, inconsistent with other axioms of logic. In particular, we might believe that x is above 0.2 and also below 0.1 with probability 0.5 or something like that. And then we are not going to be able to place all these demands. And so real valued coherence is this constraint that's supposed to allow all of this, that like, these beliefs just like are coherent with respect to reasoning about real numbers, in the same way that propositional coherence requires that they're coherent in like the Boolean algebra sense. Yeah.
Could we ask not for the real value coherence, but something like epsilon rational number coherence? So like all the inequalities and equalities hold within the epsilon, and the
Yeah.
epsilon gets finer each time. Or
Yeah.
is that what you meant?
So I mean both. I think like the next slide is on the epsilon version, and then like the slide after that is like, well, maybe we want the actual version. So
Because like real computers couldn't do the real value coherence
yeah, this
because of
seems
the incomputability of real numbers. And also like do you like there is this fact that like the inequality sign is uncomputable just in general. It's
yeah.
like you can construct a number type to be this way, so the inequality would be finite.
Yeah, so even if we construct theoretically this nice object of like, here's the actual real valued coherence, I agree, it seems like really we want like to think, for computers' sake, we want to think about these like epsilon slices. So if we just jump to that idea, then a picture, like a partial picture of what this might look like in implementation, is like, similarly to how we enforce propositional coherence on some finite set of propositions by enumerating all the worlds and assigning probability to each, we can imagine the epsilon discretized real coherence as dividing up all the real valued variables into these little slices and assigning probability to each of those. And then similarly to how for propositional coherence, we can extend it to an infinite number of sentences by assuming that all but finitely many of them, like assuming that the large sentences that are not like just compounded from small sentences by like conjunction and disjunction, are all independent and 50-50, so that we have like an easily computable probability distribution over them. We might similarly try to assume that any real valued variable that's not like already in the small beliefs, or some simple compound like adding together real valued variables that are mentioned in the small beliefs, or maybe some more complicated set of real valued operations that we're closed under. But anything that doesn't fall into that, we assume to be independent and uniformly distributed.
Sorry, what does it mean to be uniformly distributed for a real value?
So yeah, these need to be bounded value, similar to the logically uncertain variables in the logical induction papers. So I think that in order to decide, oh, this is properly typed as a real valued variable, it actually has to come with bounds. That it's like, we know that this is between like -1 and 1 or whatever.
Sorry, is it true that you have to like? Sorry, so in order for in logical induction, in order for a logical uncertain variable, in order for the logically uncertain variable to be computed, like to have a definition, there has to be a small beliefs about it being inside of the bounds, or what, or how, or
Yeah, so I think the logical induction paper makes the simple choice of saying like, it actually needs to be between 0 and 1, just for simplicity. They only discuss logically uncertain variables between 0 and 1. But yeah, I think we could generalize that to arbitrary bounds. I guess, yeah, the question is like, is it something like the deductive process has to have already proven that the bounds apply to that variable? That seems like a somewhat harsh version, but I'm not sure what else would work.
Okay.
I think is it like maybe like a good version would be like we actually craft the language, so we don't just use like piano arithmetic or something. We craft the language to have a type which is like a bounded real, and the bounds are like part of the type of a real, so that we can just syntactically check, is this a bounded real? I think that
Makes
would
sense.
probably be like a good way of doing it.
Makes sense.
So like Roman talked to me in his last meeting about this dot grid version. So I think the dot grid makes sense for the specific case of the like the belief about a future belief, because we can stipulate that the beliefs be multiples of some epsilon that grows with time, or shrinks with time rather.
So a brief question for me. I guess I'm not totally
Yeah.
sure what the issue is with variables that are outside the bound 0 to 1. Can't we do something like, I don't know, actually, what would it be? Take an inverse tangent or something and map it to 0 to 1, like log odds or what have you?
Yeah. So it's kind of not that big of a constraint, because we can map real numbers that are of unbounded range into a bounded range. But in order to say, we just have like a uniform distribution like I was here, obviously we need a bounded range in order to define a uniform distribution. And then as another kind of implementation issue that comes up, not directly relevant to what we're talking about, but maybe like somewhat relevant, like one thing that we might want to do in order to do some kind of real valued coherence is have market prices directly on real valued variables instead of only on propositions. And if we do something like that, which is like, I'm not necessarily advocating for that approach, but if we did do something like that, then the fixed point theorem that we use to construct logical induction requires bounded ranges. So you couldn't have a price on like, say that you're not comfortable bounding utility. You want to have unbounded utility that could go arbitrarily high or arbitrarily low. Then you couldn't have like a market price on utility using the fixed point theorem that's used to construct logical induction, because you might have a belief, you might have a trader that's like, oh, I'm going to just add 1 to the utility, right? Like this trader always says, oh, the utility is actually 1 higher than the market thinks it is. And there's no fixed point to this belief. And so we don't have like the fixed point guarantee without these bounded ranges.
Sorry. I'm not really that familiar with the fixed point theorem, like in the specific details of its working. But wouldn't that trader be outweighed by other traders? Like it can do this stuff indefinitely, and like it would be because it has limited budget or something like that. Isn't there like a budgeter that? Sorry, yeah.
Yeah, that depends on like the mix of traders. So like you could try for a result like that, but it becomes more complicated.
Like I recall in the logical induction papers there was something about like the budgeter that like keeps everyone in check. So like maybe this strategy would be like modified by the budgeter to be for it to become applicable for the fixed point theorem.
I could be wrong, but I think that it doesn't work out so easily. Like
Okay.
like this trader is, I mean, suppose that this is the only trader there is. Then this trader is like I don't think that just pointing out the limited budget fixes the problem. I could be wrong though.
Okay. We are talking about like the market where there is like a utility market also, right?
Yeah.
Oh, then I'm not sure about that. So yeah. Okay.
So yeah, I'm not sure, but at least it's not like obvious from the fixed point theorem, because the fixed point theorem requires this boundedness. So anyway, yeah, of course, it seems like it could be more elegant to consider the real coherence more generally. So like any bounded range real value variable without discretizing. Oh, sorry, I got myself a bit confused here. So yeah, talking about the difference between just belief over beliefs, which is like the direct thing that I'm kind of proposing here, versus this real coherence over all of the real valued variables instead of just beliefs about future prices. And so the future prices we can force to this dot grid, because we can, like if we round with small enough an epsilon, it doesn't threaten the logical induction criterion, so we can actually just say, look, the prices are actually on these dots. But for arbitrary real valued variables, if we want to consider real coherence over those, then those cannot be forced to conform to a dot, since that might be like logically inconsistent. Like pi, for example, is not going to fall on one of these dots. So then we have to use
what can fall? What can fall? Number pi.
Yeah.
Oh, okay.
Like beliefs about pi fall on dots, sure, but like the number pi itself doesn't fall on one of these dots. And so we have to use these like bins instead.
Well, yeah. Then maybe we should like just get around with beliefs about the proximity, about where the pi lies.
Yeah. 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 Take care, Paul.
I actually, before I go, I had just a like minor nitpick on this slide. When you say multiples of some epsilon n which grows quickly enough, do you mean shrinks quickly enough, or what?
Yes. I mean, okay. Yeah, apologies.
Like 1 over epsilon n grows fast.
Yeah.
Okay. I will probably watch the recording a little bit later, but I do have a hard out at 11. So take care.
Take care.
Goodbye.
Yeah, and I only have a little bit more anyway. So Yeah. So this is like some more technical things like, okay, if we're just considering the actual real value coherence rather than discretization, what does real value coherence mean exactly? So here are some formal things that we might ask for. So,
So sorry, I know it's quite an interruption, but since Hannah and might need to go, like I need to ask. I forgot to ask that the time for next week. Or what time do you want for the co-working and maybe plus with Ben session? Also, that depends on when Roman will have something ready.
So for the co-working, I can't do Monday. I cannot do Monday next week. But also the time you proposed for Tuesday doesn't work for me.
Okay. How about Wednesday?
Yeah, I think Wednesday works. Yeah,
Wednesday works for me too. And please send the email like with the meeting.
Okay, then maybe I'll you create the event this time. Yeah. Okay. For the Wednesday meeting, so it's like the same time on Wednesday, right?
Yeah. Like for me, it would be convenient on the same time on Wednesday. Yes.
So is it? Hannah, do you think that? Is it? Are you also thinking about that the same time?
yes. So
could you guys do half an hour earlier? Because I actually already arranged with Ben to talk like sometime before that. So
yeah, it's fine with me. If please send the invitation so I could know what, like, with all of the time shifts, because it's hard for me to understand like what time you're talking right now. And yeah,
but you're sure that it's okay for you if it's
yes, the Wednesday is free, like fully free for me. Yeah.
Okay. Okay, so just let's check with Hannah. Just half an hour earlier from the usual time.
Yeah, that works for me.
Okay. Thanks. Okay, I'll create the event. Yeah, and send the link. Google Calendar. Yeah. Oh, okay. Bye.
Cool. Bye. Yeah. So A is like, well, contradictions of real valued logic, like A can't be less than B and also greater than B. It should have probability 0. This seems pretty obvious, but my question is, well, okay, what axioms exactly are we enforcing? Those axioms have to be decidable in order for this to be computable. And I haven't looked into like what axiom sets we might enforce there and whether they're decidable yet. B is like individual beliefs like x is greater than 0.2, x is between 0.1 and 0.5, etc., should be consistent with some overall distribution on x. I think this might be equivalent to A on some interpretations. And then similarly, like multivariable beliefs, like x is greater than y, consistent with some joint distribution. So I think like A, B, and C might all be kind of equivalent. Or like C generalizes B, obviously, but like both of them might be following from A for some proper interpretation of A. And then D, joint distributions on multiple variables marginalized correctly. So here P is like a probability density function, saying like when we integrate out variables, then it equals like the beliefs that we have for just the one variable. So some version of this follow directly from propositional coherence in the sense that if our joint beliefs are expressed just as conjunctions, which they need not be, of course. Like we see examples like this, like X is greater than Y, isn't like some conjunction of statements about X and Y. But we can express joint probability distributions as conjunctions, as like, I should say, beliefs about conjunctions, in which case, then this marginalization type thing should follow just from propositional coherence. And then E, distributions on mathematically related random variables are appropriately related. So this handles more complicated things like if Z is X plus Y squared plus 2, then Z is like a random variable that we've formulated out of the random variables X and Y with some mathematical expression. And then that should be like appropriately related. Like the distribution on Z should be derivable from the distribution on X and Y. And I think this doesn't follow from like B, C, and D. Maybe it follows from some version of A.
What is so? What do you mean? So, we need to wait for the deductive process to prove all of the statements of this type for us to have for us to impose them, right?
Yeah, like if we don't yet know that Z equals X plus Y squared plus 2, right? Then yeah, I agree.
Well, wait, sorry. So what? So we don't wait for the. Do we wait for? Yeah, Hannah.
Bye.
Yeah, go. I just asked this one. Yeah, goodbye. I will just ask this one question and we'll probably head out.
Yeah.
So do we like on each day we introduce some random variable, and do we wait until the deductive process tells us everything about the relationship of those beliefs, or do we not wait? Well,
so I think there's like things we do wait for and things we don't wait for. So if we, like with A, we rule out all real valued contradictions from some set of axioms, then it's like propositional coherence doesn't wait for propositional formulas to be proved. It just knows that like you can't have A and not A. You can't have like
but how?
You
how
can't
does it do that?
I mean, it would have to, like, again, it has to be a decidable set of axioms so that we can just like run the computation. Much like with propositional logic, you can just check if something is consistent or inconsistent, so that you can just like rule out all the inconsistent worlds, so that you can specify a computable probability distribution which respects this notion of consistency.
Okay.
And similarly here, it's just kind of a generalization of that, of like, we're checking a notion of consistency that's more than just propositional consistency.
So yeah, for finite amount of real value variables, there is a finite amount of axioms to check from which everything would follow. So we don't need to check like every single combination of every variable with each other is with other variable.
Yeah.
Everything will just follow from the finite set of axioms which is checkable.
Yeah.
That kind of hard to get my head around, but yeah, okay. Thank you. I guess we should end now because no one else is
Yeah.
there.
The last slide isn't that important anyway.
Okay.
Yeah. Here's the last slide, and take care.
Goodbye.
Bye.